Hello and welcome. Today we're going to be talking about factoring polynomials by grouping. So we are going to go beyond simply factoring out a greatest common factor, and we're going to be factoring polynomials completely. The first thing I'd like to check is to see if each of these polynomials have been factored correctly. So what I am going to do is I'm going to take the factored form of each polynomial, so the red expression beneath each trinomial, and I'm going to FOIL it out. My goal is to see if after I FOIL the red expression, if it matches the black polynomial above. So let's test it out and see. Distributing my n times n gives me n squared. N times 7 gives me a positive 7n. Then distributing the 1 times n is a positive 1n, and 1 times 7 is a positive 7. Looking at this expression, I may now combine like terms in the middle. N squared plus 8n plus 7. So if our expression had been factored correctly, then when I FOILed out the red polynomial, the trinomial that I got should have matched the original. Now if you notice, it does not match. At the end of the first, there is a plus 6, while at the end of the second, there is a plus 7. Since these do not match, this has not been factored correctly. Moving on to the second one. Again, I'm going to FOIL out this red expression. That is the factored form of the polynomial above. I am going to see if this was factored correctly by FOILing out the expression. If it was factored correctly, then the end result will match my original polynomial above. So I start by distributing the n times n is n squared. N times positive 8 is a positive 8n. Distributing my 6, I have plus 6n, and 6 times 8 is a positive 48. Combining like terms in the middle, I end up with n squared plus 14n plus 48. Now this trinomial should match the original trinomial in black above if it has been factored correctly. Now, since those two do match one another, we can conclude that that red factored polynomial is, in fact, the correct form of my trinomial above. So this is a yes, it has been factored correctly. Okay, go ahead and take a moment to pause the video and check the next two on your own. When I FOILed the first on the left, I did get a trinomial that matched my original, so my conclusion was that yes, this is the correct factored form of my original polynomial. To the right, when I FOILed out my red expression, the end result did not match the original trinomial. There is a minus 5n in the middle of the original, whereas a minus 7n in the middle of my FOILed out version. Since these do not match, I conclude that this red expression is not the correct factored form of my original. Now let's go ahead and recap for a moment, factoring out a greatest common factor from each of the given polynomials. For the first, looking at 2x squared and 7x, I see that they both have an x in common, so I'm going to take out an x. I am unable to take out any coefficient because 2 and 7 do not have any common factors. So I simply take out an x. When I take out an x from my 2x squared term, I am left with 2x. When I take out an x from my 7x term, I'm left with a positive 7. Remember, you may check your answer by distributing that x back in. Whatever you get should match your original expression. To the right, I'm first going to look at my coefficients, 15 and 20. Remember, if you are unsure what the greatest common factor is, make a list of the factors. 15 factors down into prime factors of 3 and 5, while 20 factors down into prime factors of 2, 2, and 5. The only thing that they have in common is a 5, so my coefficient of my greatest common factor is 5. Now let's look at the variables. I have 3 x's here and 2 here. The most I can take out is 2. So I'm going to take out 5x to the second power. From the 15, x to the third, when I take out a 5 from the 15, I have a 3 left. From x to the third, when I take out x to the second, I have just x to the first left, or x. From my negative 20, when I factor out a 5, I'm left with a negative 4. I had x to the second, and I took all of those x's out, so I have no more x's left. Again, to check your answer, you may distribute that 5x squared back in, and what you get should match your original binomial. I'm going to skip down 2 lines to this third row. These are a little bit different looking, but we actually go about them in the exact same way. Looking at this expression as 2 parts, here's my left and here's my right, I see something repeated between the left and the right half. That would be the x minus 2. This whole expression is stuck together, and therefore we can consider it as a factor. I am going to factor out that entire x minus 2, so I'm going to take all of this out to the front of my parentheses. Taking out the x plus 2 from my entire expression, I am then left with, in parentheses, a 5x minus 3. So remember, we're basically doing distribution in reverse. To the right, I see an x minus 3 repeated. This entire expression is stuck together because it is in parentheses. So I'm going to take that entire x minus 3 out to the front. So I have an x minus 3. When I take that out, my first term I am left with a 7x. And from my second term, taking out that x minus 3, I am left with a plus 4. Go ahead and try the remaining 4 on your own after pausing the video. For the first, you should have 4x to the third on the outside with 2x minus 3 on the inside of your parentheses. Second, you should have factored out 3x to the third, leaving you with 6x to the second plus 3 inside parentheses. To the bottom left, you should have factored out an x minus 2, leaving you with a 6 minus 3x in the other parentheses. You may also have written yours with the x minus 2 in front and the 6 minus 3x second. Either is okay, it does not matter what order they're in. And last, to the right, you should have x plus 3 times another x plus 3. Now remember, you can go one step further and simply say this is x plus 3 times itself 2 times. So x plus 3 squared. We're going to now go into factoring by grouping. Step 1 when you are factoring by grouping is we are going to identify any greatest common factor of the whole polynomial if there is one. So I look at this entire polynomial, all 4 pieces, and see if there's anything in common. I have a 9 and a 3. Those are both divisible by 3. And so is 15. But 5 is not. Since all 4 terms do not have a common factor, I am unable to factor out a GCF. So step 2. I split the polynomial into 2 parts. I'm going to simply draw a little line separating the left and the right half of my polynomial. I have 2 terms on the left and 2 terms on the right. Step 3. We are going to factor out the greatest common factor of the left and of the right separately. So looking at this left half of my polynomial, I see there is a 3 in common, and there's also an n squared in common. what's left after I take the 3 out of the 9, I have a 3. And from the n to the third, when I take out n to the second, I have just one n. Plus, factoring a 3 out of my 3 left me with just a 1. And taking out my n squared leaves me with no n, so I simply have 3n plus 1 in my parentheses. Now on the right, I'm going to again factor out the greatest common factor. Be careful because we are adding on the right, so I put a plus sign. And then looking between my two terms, I see a greatest common factor of only 5. Factoring out a 5 from 15n, I'm left with 3n. Factoring out a 5 from 5, I'm left with just a positive 1. Now from here, step 4, look at the entire polynomial and factor out the greatest common factor, if there is one. If you look, I see the 3n plus 1 repeated, just like we saw on the last slide. So I take out this 3n plus 1, and what is left on the inside of the parentheses is my 3n squared and my plus 5. This is the factored form of your original polynomial. We're going to go ahead and go through these 4 steps again. Step 1, I'm going to identify any greatest common factor and factor it out. In this first example, there are none. So I move to step 2, where I split my polynomial into 2 parts. Step 3, looking at the left, I see a greatest common factor of 5x to the second power. Factoring that out, I'm left with 8x minus 1. And from the right, I see a greatest common factor of a positive 8. So factoring that out, I'm left with 8x minus 1. Step 4, I look for the greatest common factor of the entire polynomial. That would be this 8x minus 1. Factoring that out, I am left with the 5x squared plus 8 in my second set of parentheses. Go ahead and take a moment to pause the video and try the next 3 on your own. For the first, you should have a minus 4 on the outside with 4a squared plus 3 in the other set of parentheses. For the second, you should have factored out an x minus 3 with a 4x squared plus 5 in the second parentheses. For the third, you should have factored out an r plus 4, leaving a 4r squared plus 1 in the second parentheses. In this next set, there's only a slight change. We still go about it in the exact same way. Step 1, look for any greatest common factor among all 4 terms. In this first example, the 4 terms do not all have a common factor, so I simply go straight to splitting my polynomial into 2 parts. The first part, there is a 7b squared in common, leaving a b plus 6 in parentheses. Here I'm subtracting now. I bring down this sign, and my greatest common factor between the 2 is a 2. Now I've taken out a negative 2, which will make my b positive, and it will make my negative 12 become a positive 6. Now you can see my b plus 6 is matched, so I'm going to factor out that b plus 6, leaving me with 7b squared minus 2 in parentheses. Down to the left, again there is no greatest common factor between all 4, so I look at the left and take out an x squared, leaving me with x plus 2. I am now subtracting again, so I take out a negative, and the only thing in common between these 2 is a 1, so I take out a negative 1, leaving me with positive x plus 2. Now I have an x plus 2 in common, so I factor those out, and that leaves me with an x squared minus 1 in the second parentheses. You will learn in future lessons that you can factor this further, but we're going to stop here. Go ahead and pause the video and try the next 3 on your own. Go ahead and take a second to check your answers. And I hope you enjoy the rest of your day.